temperature difference is 160 degrees, it won't output any energy. Whereas the evacuated tube is modeled to still output up well above 300 degrees. But the problem is, even in the worst case scenario, if I want to put 80 degrees Celsius into my storage tank and it's minus 40 degrees outside and sunny, that's 120 degree Ti minus Ta, which is here. And you can see that at that point the flat plate is a little bit more efficient. It's producing a little bit more energy, but not much. And just at that one very, very extreme that you're hard to find. Yesterday it was minus 25 degrees Celsius. So that would bring us back here, and that was the coldest day of the year so far, I think. So even if it was trying to put 80 degree water into that storage tank, the flat plate collector is modeled to outperform the evacuated tube collector. My observations have been that this curve isn't right, and I suspect that this curve also won't be followed exactly. But that's how I did the math. So that's what we have planned for the house. Any questions on that? I just have a couple more slides here. This one is what's currently in the house today. So the solar panels, this diverter valve isn't exactly as shown. It's actually in this line. It's a T with it in this line, and it short circuits. But basically the thermostat behind raw determines whether or not the flow goes through this baseboard heater. When that thermostat wants heat, the flow will go through here. When that thermostat doesn't want heat, then the flow goes through these slant fin heat emitters that are in the basement. And they're all bad choices in hindsight, because the flow through this pipe is about a quarter of the design flow rate. So I said that in order to eject 1 kilowatt hour of, if the panels can produce 5 kilowatt hours of energy, the maximum this emitter would produce is about 2 kilowatt hours, is the most it can radiate, 2 kilowatts into the room. So there's no way that this can use all the energy that the panels are producing. And so as a result, what we've been seeing is the temperature of this fluid going back into the panel is quite high. It's going back up 50 degrees. I've seen, you said you saw them 70?
Yeah.
And the reason is this emitter is taking out its 2 kilowatts of heat, and then the rest of the heat is just sort of being cycled and lost, or we're failing to collect potential heat. The basement or the crawl space is even worse. I don't know if you saw if you remember the low flow values, but the slant fin radiator doesn't even emit. It's like less than 200 watts at low flow and temperature. So the performance is really poor. The performance of these two is worse than the performance of this one, and neither of them is. But backing up a bit, the whole reason we have this design at all was we did the original design that I've shown you, and then Ron asked us, it came to be that the home was going to build a museum here after the original design, and he asked if there was anything he could do with the solar system, and we thought, well, we'll just put some emitters in the crawl space. He was going to heat it anyway, and some heat will be dumped there, and if it's not, there's no real loss. So it's sort of everything he's getting is for free. But I guess as an engineer, I'm looking back at this design we did and thinking it could have been more optimum. We could have been transferring more heat if we put a little bit more thought into it and different selection of materials. The other thing I want to note is only this one length of pipe is insulated. All these other pipes, since we're just heating the crawl space anyway, we've left uninsulated. And now that's, as sort of complaining before that no insulator is a really good insulator, they're all conductors and they lose heat. My other problem is now we have all this pipe in free air, but air itself is a really good insulator, and when you want to lose heat just by running a pipe through the air, it turns out that you don't lose, it seems like you don't lose any. If you don't want to lose heat and have an insulated pipe, you lose more than you would like to. but that's just the nature, I guess, of thermodynamics. So some of the, I believe I've talked about most of the limitations of this current design already. The lack of solar storage means that those temperatures run up and there's nothing we can do with it. If we had a storage tank of some sort, then there's no way that 60-degree water would be going back to the collectors, or 60-degree glycol. It would be being stored in the tank, and then even though the rate of heat emission from these emitters is slow, if there's a storage tank, then it can go all night and release that heat slowly. There's also an issue potentially with the collectors. We possibly should have connected those in parallel instead of in series, where Rob is measuring the flow to those collectors, and it's slightly slower than the manufacturer's spec. So that's probably, we'll probably change that, or we'll look at that anyway when we go to move the home to its final location. And in general, using solar for space heating is a poor fit in our province, because when you need the most heat is when you have the shortest day. But domestic hot water you use all year round, and it comes into the house very cold all year round, so it's a great application. It's a good application for solar, and it's not being used here. It's not needed. So sources of information, these are some I thought about. I used to always have sources of information as web locations and publications, but Google is a good guide to the web locations. I've listed Home Power is one of the publications I use, and I've heard a bit about the Solar Pro. I looked at their webpage, but I haven't read their magazine. But then I was thinking, people in groups, everybody here today came out to be in a live session, so I thought of some of the sort of live groups. Have you been to the Screen Drinks before?
No, I'm not.
So this is a really good one. It's a very informal organization. People get together and talk about green topics. The Saskatchewan Environmental Society and Eco Network are both, they have different events. The Canadian Solar Industry Association has conferences, as well as the Canadian Hydronics Council has conferences, and they talk a lot about maybe, they usually have some sessions on solar, and they talk a lot about the other aspects that you can't just put solar on your house and expect it to heat the house well, so they talk a lot more about the hydronic heating and emitters. Does anyone have any comments or questions?
That 1,000 liters storage tank, what type of material is that?
I don't know, it's like I always think of it as an above ground swimming pool. Yeah, it's some sort of plastic.
What manufacturer or who makes it?
It's either, it has SSTS or SSPS.
SSTS, I think.
They're out of, I think, the New England area in the States. But I saw another one at the last conference we're at. Somebody was making square ones, which would both be easier to insulate and more space effective in the basement.
They're more commonly or readily available too, because you usually get chemicals in them for whatever. I know because I've got a couple of at home.
Oh, okay, just storage tanks, but not. Are those the ones I'm thinking of? It's a pre-insulated tank design.
Yeah, you could probably insulate it fairly inexpensive, because a lot of places will just throw them away.
Yeah.
But I know like a regular polyethylene tank, I don't think would be suitable because they're not meant to withstand those temperatures.
Yeah.
Do you know how they're going to integrate the vacuum tube collector into the eventual?
My understanding is it's not intended to be part of the final home. It wasn't part of the original design.
That's what I've been told too.
And so here's, well, those ones, the evacuated tubes here are a little bit different than most evacuated tubes, and I couldn't find certification on this exact one. I don't think I found it. But most evacuated tubes are similar to this, but longer. So this copper thing is it's called a heat pipe. It's also evacuated, and then this is a double wall. I'll pass this around, you guys can have a look. If you take this heat pipe out, you can shake it.